Hi there, this is Science Lady, grade 11 and 12 chemistry, and today I'm showing you the complete summary of acids and bases. Subscription to the Science Lady channel is free. Subscribe and click notification. Please note that the exam guidelines in caps are followed. The complete summary on acids and bases can be done on a double folio paper. So pause the video and get your paper ready. In this video, I discuss the topics or concepts that are required to be learned. Therefore, listen carefully so as to write it down correctly. When you revise, use the video and pause after every concept to see if you can recall on your own. Know the following definitions and concepts well and give examples where applicable. Write down the concepts but leave a line open between each concept. Pause the video now so that you can complete this table. Again, you will pause the video, write down the concepts, and leave a line open between the concepts. Again, pause the video, write down the concepts, and leave a line open between them. You should have completed 1.5 double pages by now. The rest should be left open for the calculations that will follow. You should now be ready to listen and receive the definitions for each concept. Write it down in the lines left open. You can pause the video at any time when I'm going too fast. An areneous acid is a substance that produces hydrogen ions in brackets H positive or hydronium ions in brackets H3O positive when it dissolves in water. An example, HCl plus H2O arrow H3O positive plus Cl negative. An areneous base is a substance that produces hydroxide ions in brackets OH negative when it dissolves in water. Example, NaOH arrow Na positive plus OH negative. A reminder to always place aqueous AQ in brackets behind the ions. A Lowry-Bronsted acid is an acid where a proton in brackets H positive ion is donated. A Lowry-Bronsted base is a proton in brackets H positive ion is accepted. Examples, HCl plus NH3 arrow NH4 positive in brackets AQ plus Cl negative in brackets AQ. Another example, HNO3 plus NaOH arrow NaNO3 plus H2O. Strong acids ionize completely in water to form a high concentration of hydronium ions. Examples of strong acids are hydrochloric acid, which is HCl, sulfuric acid, which is H2SO4, and nitric acid, which is HNO3. Weak acids ionize incompletely in water to form a low concentration of hydronium ions. Example of weak acids are ethanoic acid, which is CH3COOH, and oxalic acid, which is brackets COOH, close the brackets, 2. A strong base dissociates completely in water to form a high concentration of OH or hydroxide ions. Examples of strong bases are sodium hydroxide, NaOH, and potassium hydroxide, KOH. A weak base dissociates incompletely in water to form a low concentration of hydroxide ions. Example of weak bases are ammonia, NH3, calcium carbonate, CaCO3, potassium carbonate, K2CO3, and sodium bicarbonate, NaHCO3. A concentrated acid or base contains a large amount of acid or base in proportion to the volume of water. You can also say a concentrated acid or base contains a large number of moles of acid or base in proportion to the volume of water. A diluted acid or base contains a small amount or a small number of moles of acid or base in proportion to the volume of water. An amphylite or amphiprotic substance is a substance that can act as an acid or as a base. A good example is water, H2O. Hydrolysis is a reaction of any salt with water, but let us use the simple table salt NaCl as an example. So write down NaCl plus H2O, arrow, Na positive, aqueous, plus Cl negative, aqueous. Monoprotic, diprotic, and triprotic indicate how many protons, H ions, can be donated as an acid. Examples: monoprotic can donate 1 proton. HCl is a good example. Diprotic, H2SO4, can donate 2 protons. And H3PO4 can donate 3 protons. The equivalence point of a titration is the point at which the acid has completely reacted with the base, and vice versa, where the base has completely reacted with the acid. The end point of a titration is the point where the indicator changes color. Kw can be defined as the equilibrium constant for the ionization of water, or the ionic product of water, or the ionization constant of water. It can be written as Kw equals, place in square brackets, H3O positive, close the square bracket, multiplied by square brackets OH negative, close the square bracket, equals 1 times 10 to the power 14 at 298 Kelvin. Remember that square brackets indicate concentration. So in other words, we can say Kw equals the concentration of hydronium ions multiplied by the concentration of hydroxide ions is equal to 1 times 10 to the power 14. Autoionization of water is the reaction of water with itself to form hydronium ions and hydroxide ions. Example, H2O plus H2O, arrow, H3O positive, aqueous, plus OH negative, aqueous. In other words, water plus water, arrow, hydronium ions in a watery solution and hydroxide ions in a watery solution. Write down the reaction equations of aqueous solutions of acids and bases. I'm going to give 3 examples, and I'm going to mention the phases that you must write in brackets behind. First example, HCl in brackets G plus H2O in brackets L, arrow, H3O positive in brackets AQ plus Cl negative in brackets AQ. Second example, NH3 in brackets G plus H2O in brackets L, arrow, NH4 in brackets AQ plus OH in brackets AQ. The third example, H2SO4 in brackets AQ plus 2H2O in brackets L, arrow, 2H3O positive in brackets AQ plus SO4 2 negative in brackets AQ. You need to identify what a conjugated acid-basis pair is and give examples. So when an acid loses a proton, a conjugate base is formed. Those two are then called a conjugated acid-base pair. Similarly, when the base accepts a proton, it then forms a conjugated acid, and the two is called a conjugated acid-base pair. So make sure you have a few examples ready for this. I want you to write down the neutralization reactions of common laboratory acids and bases. I will mention the phases behind each substance. I'm going to give you, looks like 6 examples. Here we go. HCl in brackets aqueous plus NaOH in brackets AQ, arrow, NaCl in brackets AQ plus H2O in brackets L. Next example, HCl in brackets AQ plus Na2CO3 in brackets AQ, arrow, NaCl in brackets AQ plus H2O in brackets L plus CO2 in brackets G. Next example, HNO3 in brackets AQ plus NaOH in brackets AQ, arrow, NaNO3 in brackets AQ plus H2O in brackets L. Next example, H2SO4 in brackets AQ plus 2NaOH in brackets AQ, arrow, Na2SO4 in brackets AQ plus 2H2O in brackets L. Next example, bracket, COOH, close the bracket 2, and then in brackets AQ plus NaOH in brackets AQ, arrow, bracket, COO, close the bracket, 2, Na, 2, and then in brackets AQ, plus H2O in brackets L. Next example, CH3COOH in brackets AQ plus NaOH in brackets AQ, arrow CH3COONA in brackets AQ plus H2O in brackets L. The hydrolysis of the salt of a weak acid and a strong base results in an alkaline solution, so therefore the pH will be bigger than 7. Write down examples such as sodium ethanoate, sodium oxalate, and sodium carbonate. The hydrolysis of the salt of a strong acid and a weak base results in an acidic solution. Therefore, the pH is less than 7. An example of such a salt is ammonium chloride. By now you should all know the pH scale, but I want to remind you. So the pH scale measures the acidity of a solution. It ranges from 0 to 14. Between 0 and 7 you will find acidic solutions, and between 7 and 14 you will find basic solutions, and 7 indicates that the substance or the solution is neutral. Know that the greater the number of ions in a solution, the better the conductivity of a solution. Titration is a practical process to determine the concentration of either an unknown base or an unknown acid. It is important to know the correct definition. It is also important that you must be able to draw the setup, draw the apparatus, show the indicators, know about safety precautions, exactly how to execute the procedure, so the method of the procedure, and what measures will you take to ensure reliable results. This is a drawing of the practical setup for a neutralization reaction that we call titration. There will be a burette, that's the long cylindrical tube there, and the markings start at the top, so the 0 will be at the top coming down, because at the end of the day you want to know how much of the volume was used. Then please note that the burette is clamped to a stand. The burette also has a little stopcock, a little tap that allows for letting the acid or the base into the conical flask drop for drop. Inside the conical flask you will then also have an acid or the base, all depending, but an indicator is added to that. Now the indicators will be determined by which kind of acid or base you use. If it's a strong acid and a strong base, you will use a certain kind of indicator. When it's a weak acid and a weak base, we've already discussed this. Then also please make sure that you place a piece of white paper on the stand here. That will help you to see the color changes very easily. You will determine the end point therefore easily. The moment the color changes. That's the end point that has been reached. Make sure you can draw this, but also please understand this. You need to know the difference between the properties of acids and the properties of bases. Just to run down quickly, properties of acids will be, it tastes sour, it has a pH less than 7, and it conducts electricity in a solution. Properties of bases, it tastes bitter, it feels soapy, and it has a pH more than 7. A proteolytic reaction is an acid-base reaction. So all acid-bases reactions undergo proteolysis. The products that form from acids and bases, I will mention 4. An acid and a base, the product will be salt and water. An acid and a metal oxide, the product will be salt and water again. An acid and a metal, the products will be salt and hydrogen gas. And an acid and a metal carbonate, the products will be salt, water, and carbon dioxide. Ionizers means the process whereby covalent compounds separates to form ions for the first time. Example, HCl, that is the covalently bonded molecule, separates into H positive ions and chloride ions. Place AQ behind these ionic substances. Dissociates means the process whereby ionic compounds separates into their different ions in the presence of water. Example, NaCl separates into Na positive in brackets AQ plus Cl negative in brackets AQ. First, you need to know what is the definition for an indicator. An indicator changes color at definite pH values. Place in brackets endpoint. You also need to know the following 4 indicators, as well as their color range and their pH range. First one, methyl orange. The color range lies between red and yellow, and the pH range between 3 and 4. Bromothymol blue is the next one. Its color range is between yellow and blue, and the pH between 6 and 7. Phenolphthalein, the color range is between colorless and pink, and the pH range is between 8 and 9. And then you get the universal indicator. The color range lies between red to purple, and the pH is right in the middle at 7. First, you need to know what is a standard solution. A standard solution is a solution with a known concentration. Then you also need to know what is an alkali. An alkali is a soluble base. This is an example of a titration reaction. The titration of a strong acid HCl against a weak base, ammonium hydroxide. So you will write down the equation NH4OH plus HCl. Please place a double arrow because it's a reversible reaction. That will form ammonium chloride NH4Cl plus water H2O. Now, you will find in this reaction the strong acid and the weak base that the concentration of the H ions, or the hydronium ions if you like, is bigger than the concentration of the OH ions. and therefore the pH will be in the region of an acid, which means it's less than 7. The endpoint, we say, is therefore acidic. Now, if you draw a graph, you will have pH on the y scale, on the y-axis I mean, and you will also then indicate the volume used of the ammonium hydroxide. The graph will always have this kind of curve. In this case, because it's strong acid and a weak base, your endpoint will be reached somewhere in the acidic range. So in this case, somewhere between 4 and 5. Make sure you understand this and you can draw similar graphs. From the acid ionization and base dissociation equations, we can calculate the equilibrium constant for an acid or the equilibrium constant for a base. Now let's first look at the acid. How to calculate the ionization constant of an acid. Let's look at the example that I give you. HCl plus H2O, arrow, H positive plus Cl negative. In this equation, you can recognize H positive and Cl negative as your products and HCl and H2O as your reactants. So the equilibrium constant for the acid Ka is equal to the concentration of the products over the concentration of the reactants. Please note that you do not show the concentration of water, of H2O, because water is neutral. Similarly, if we calculate the dissociation constant of a base, Kb, let's look at the example. Ammonia is your base plus water, arrow, ammonium, which is NH4 positive plus OH negative. Therefore, equilibrium constant for the base will equal the concentration of the products over the concentration of the reactants. So it will be the concentration of NH4 positive multiplied by the concentration of OH negative over the concentration of NH3. Again, we leave out the concentration of H2O because water is neutral. In previous grades, you've used the formula C equals N over V. It means concentration is mole per volume. And you also use the formula N equals M over Mr, which means mole equals mass per molecular mass. But here, because you are working with titration and unknown acids or unknown bases, you may combine the above formula into Na, the mole of the acid over the mole of the base equals the concentration of the acid multiplied by the volume of the acid over the concentration of the base multiplied by the volume of the base. So it is therefore the preferred formula to use when calculating the concentration of the unknown substance, whether it is the acid or the base. But you can also obviously use it to calculate any of those factors if it is unknown. pH calculations. Now the formula to calculate pH is pH equals minus the log of the concentration of the hydronium ions. Let's look at the example. 0.18 grams of HCl is dissolved in 5 cubic decimeters of water. The question is calculate the pH of the solution. You will start by calculating first how many moles there are. So mole equals mass over molecular mass equals 0,18 over 36,46. That is the molecular mass for HCl, and that will equal 4,93 times 10 to the power negative 3 mole. Now that you have the mole, you can go and calculate the concentration. Concentration equals mole over volume equals 4,93 times 10 to the power negative 3 over 5 equals 9,87 times 10 to the power negative 4 mole per cubic decimeters, or decimeters cube if you like. Now this value is now your concentration of your acid. Now you can go ahead and calculate your pH. Your pH equals minus the log of the concentration of the acid, which is the concentration of the hydronium ions. So pH equals minus the log of 9,87 times 10 to the power negative 4, and the value that you will get is 3. Also note that the ionic product is a constant and has a value of 1 times 10 to the power negative 14. Therefore, if you multiply the concentration of hydronium ions and hydroxide ions, it will give you a value of 1 times 10 to the power negative 14. And with this pH of the base, OH, can be calculated. When acids react with bases, it forms salts, and these salts can become electrolytes. Now, you know an electrolyte is a solution that conducts electricity. You can go ahead and prove this by setting up an experiment. Let's look at the example. If you take copper chloride, you make a solution of that, place it in a beaker. The copper chloride solution will be in this beaker. You then connect 2 electrodes, one to the positive side of a battery and one to the negative side of the battery. The electrode connected to the positive side will be called the anode, and the electrode connected to the negative side will be called the cathode. You will also, in order to prove that it's an electrolyte, connect an ammeter into the circuit. Now what will happen is the copper chloride solution will divide or separate into chloride ions and copper ions. The chloride ions will form the diatomic chlorine gas. So it will oxidize to chlorine gas, and electrons will therefore be given off. The electrons will flow externally. As the electrons are coming in, it will combine with the copper ions to form copper. And therefore you will find at this cathode electrode that there are a layer of extra copper that is formed on top of this electrode. But the proof lies in, is there a reading or not? And yes, there will be a reading on the ammeter. This is then the proof of conductivity of the salts of acids and bases. If you study these definitions and concepts well and use this video when you revise your work, you should do very well. Aim for 80% at least. All the best for the upcoming exams. Did you find the video helpful? Then please click the like button Also subscribe, and you are welcome to ring the notification bell. Goodbye for now.